Picture this. You wake up one morning with nausea, body aches, abdominal pain, and despite sleeping all night, you are exhausted. You then find yourself running to the restroom with watery and somewhat explosive diarrhea. You think to yourself, what could this be? Well, if the year was 2023 in the summer and you happen to live in Texas, chances were somewhat high that you probably had cyclosporiasis. And today, we're going to talk about this particular parasite and focus in on what our options are for detecting it, given that it is not routinely picked up on O&P exams. And while there are molecular panels out there that include Cyclospora as a target, as our speakers will share, there's an easier and cheaper approach we can consider to quickly ID this pathogen. Welcome to Editors in Conversation. I'm your co-host, Ellie Thiel, and I'm here with JCM Editor-in-Chief, Dr. Alex McAdam from Boston Children's Hospital. Hello, Alex.
Hey, Ellie. That was a very cheerful opening.
Oh, yes, I did enjoy writing that. It was a quirky opening today.
Yeah.
So, Alex, you went on a really fun trip recently where you saw something I've always wanted to see, which is exploding volcanoes.
Yes, my wife and my two kids and I, we all went to Volcano National Park in Hawaii, and we stayed in the lodge there, the volcano house. And the staff knew it was going to erupt. They told us the night before, and then at 3 o'clock in the morning when it was erupting, they came around and knocked on each door and cheerfully called out, "We've got an eruption." And everybody went outside. It was fantastic. It was really, really exciting.
You're so lucky because we happened to be there the week before you went, and all we saw was smoke. So you are.
Yeah, it's still a beautiful place, though.
Yeah,
but having the eruption puts it over the top.
It was awesome.
You mentioned casually that this podcast was the only thing standing between you and your family vacation to Mexico.
Yes, we gotta wrap this one up quick because we're going to Mexico tomorrow for our spring break. So
nice.
It'll be fun.
How long will you be there?
A week. So anybody that listens to this and plans to email me, there will be a delayed email response.
And is this a sort of a resort beach type vacation? Good.
Inclusive. Inclusive. The way to go.
Sounds amazing.
Anyway, so we hope that you've all enjoyed previous editions of Editors in Conversation, and we ask that you please subscribe and rate or review them wherever you get your podcasts. We appreciate both positive and constructive feedback. This episode is brought to you by the Journal of Clinical Microbiology, which is available at jcm.asm.org. The podcast is supported by the American Society for Microbiology, which publishes JCM. And just as a reminder that if you are considering publishing in JCM as an ASM member, you will receive up to 50% off publication fees, which is always nice. So for today's episode, we have two returning guests that we're excited to talk to. Dr. Angela Ma, who is a clinical microbiologist at Public Health Ontario and is an assistant professor at the University of Toronto. Angela, welcome back.
Thank you. Happy to be back.
Awesome. And we are also joined by Dr. Marc Couturier, who is the director of the Clinical Microbiology Lab at NordX. Is it Nordex?
Nordex.
Nordex. Lab at Maine Health in Scarborough, Maine. And as we all know, he was previously the director of parasitology at ARUP Laboratories and was there when this particular paper and work was performed. But welcome back to the podcast, Marc, and congrats on your new job.
Thank you so much.
Marc, from where are you recording?
I'm in my parents' basement in central Maine, where I'm temporarily squatting until my new house is finished in a week.
Excellent. Well,
so yeah, I'm in my childhood basement, living the dream.
Living the dream.
Yeah. Let me also congratulate you on your new job. That's terrific.
Thank you so much. Excited to be back home.
Awesome. Well, today we are here to talk about a recent paper that you two, along with Blaine Matheson, published in JCM last month entitled Shedding New Light on Cyclospora, How the Use of Ultraviolet Fluorescent Microscopy Can Improve Diagnosis of Cyclosporiasis. And we haven't covered too many parasitology topics on the podcast, so Alex and I were pretty excited to refresh ourselves and maybe some of our listeners out there on Cyclospora, especially given that these outbreaks are not, let's say, not infrequent. So we'll dive right in. And Angela, we'll start with you. Can you kind of review for us the basics of Cyclospora? So what kind of parasite is it? Where is it endemic? And how do we usually get exposed and infected with this organism?
For sure. So Cyclospora is an intestinal coccidian parasite. And while we generally associate cyclosporiasis with Cyclospora cayetanensis, in some recent work back in 2023, actually, 2 new lineages were identified through some typing methods at the CDC. So there's actually Cyclospora ashfordi and Cyclospora hinensis now that does circulate in North America and in China. In terms of the major hosts, humans are the only major host for Cyclospora cayetanensis, and it's really distributed in all sorts of different parts of the world. It causes seasonal outbreaks in North America, but it is endemic in kind of tropical and subtropical areas, thinking Latin America, Central and Southeast Asia, the Middle East, and also North Africa. In terms of how we're getting it, it's typically through ingestion of oocysts that have sporulated already, so it's not direct fecal-oral transmission, and are typically associated with contaminated fresh produce, thinking, herbs, fuzzy berries, leafy greens that you typically eat raw, and you kind of just give a quick rinse maybe, or not rinse potentially. Or if you're in the endemic regions, of course, there is the risk of contaminated water as well. But once the oocysts kind of exist in the GI tract and invade your small intestine, the damage and the immune response really is what's causing those symptoms.
Thank you, Angela. Mark, tell us a little bit about that outbreak in 2023. What were the presentations of the patients? Was this linked to a particular product, particular food or something?
Yeah, so unfortunately with Cyclospora, Alex, we kind of suffered from this ongoing cycle of seasonal outbreaks in the United States directly linked to our food supply. And since about 2014, the case count of these outbreaks has been getting larger and larger. I truly don't think that the outbreaks are getting larger. I think our ability to detect them is getting better. So we think about molecular panels and such, getting more adoption, more FDA-cleared tests that have BioFire and pathogen, and there's a couple others in the pipeline. When they add this target, now you're detecting stuff people didn't detect before. And so, these case counts for this last outbreak are estimated at 2250 or 2270 based on CDC's reporting. We know that that's an underestimate. It's just the tip of the iceberg because that's based on who's actually testing, right? And so there's a massive cohort of clinical labs who are in the catchment area, but blind to it. So, you could extrapolate that could have been over 10,000 for all we really know. And at this point, that vehicle source of food has still not been identified. In fact, CDC closed that epi investigation, so we'll never know. And then the challenge with that is, cyclosporas get this kind of tricky life cycle where when you shed it, it's not immediately infective. So it has to go out in the environment. It has to have just the right UV exposure, humidity, temperature. Then it sporulates. Then someone ingests it, and most people don't get sick right off. It can take 7 to 21 days. So now you're talking about, potentially 3 weeks in the host and up to 28 days in the environment. No one keeps produce on the shelf that long, right? It's all gone. After that long, there's no point to go back to. And that's the CDC epi folks have said that for years. It's the hardest thing about tracking cyclospora outbreaks.
Hmm.
And you mentioned the complexity of the life cycle and how that contributes to the complexity of the epidemiology. And you also mentioned the incubation period before onset of symptoms. But can people be productively infected? Can they, without symptoms, can they be asymptomatically colonized and shed the organism?
Yeah, absolutely. I mean, with everything with Cyclospora, we wish there was more data. We wish there was more investigators. It's a difficult organism because there's no ex vivo culture and there's no model system because humans are the only hosts. So the data's really scant on it. One thing that we do know from a few retrospective epi studies is that there are immune competent hosts who can either carry it and shed it without overt symptoms, or they can go in these wax and wane type symptom patterns where, they've got a few loose stools for a day and a half or so and then it goes away, and it's the type of thing you don't really think about very much, right? I just, oh, that's an unusual stool consistency, but I feel fine otherwise. So that makes it tricky as well.
So I have a question for you two parasitologists. How do you wash your produce? Do you?
I don't.
Okay.
Oh, shame on you.
Say more.
No,
Yeah.
I'm
Throw
more
down.
worried. I'm more worried about pesticides and the stuff that humans are putting on that are chemical than I am what nature put in nature.
Okay.
So I'll wipe my apples, but I think anybody who washes raspberries is an evil human. The consistency is disgusting after you do that. How can you do that to a raspberry? It's just awful.
You can rinse them lightly.
Yeah, gentle stream of water.
I don't know if you guys have seen on TV, there's these special sprays that remove all bacteria and parasites from your fruit and vegetables.
Oh my gosh.
I don't,
No.
but I know. Yeah.
I worked
don't
with
waste
one of
your
those
money.
in undergraduate as part of my honors thesis for E. coli biofilms. They don't do anything to get it off lettuce.
Oh.
As soon as there's a biofilm, they're useless. So it's good for like superficial contamination, but it's not going to break up a glycocalyx of the biofilm.
Yeah.
People
All right.
assume that microbiologists are very fastidious about what we eat, but I think we're just like the rest of the population. Some people are, some people aren't. I'm not particularly fastidious about it. I'll eat raw oysters and carpaccio and stuff.
I just had sushi for lunch and I'll eat it over and over and over.
Yeah.
Awesome. Well, that's great. So a world-renowned parasitologist does not wash his raspberries. I think that's what I'm taking away from this particular podcast. Moving on. So Mark, back to the paper. You mentioned that Cyclospora is traditionally underdiagnosed. Can you talk about why that is and what the current kind of routine diagnostic approaches are used for it?
Absolutely. I'm going to make some assumptions about labs. So if I'm overstretching, the assumption of the field, I apologize to labs who feel otherwise. But in general, I think a lot of it is just Cyclospora is best, and I say best in air quotes because I don't actually believe that, but I'm quoting textbooks, best detected by special stains, including the modified acid fast, modified safranin, which you guys do over at Mayo. We did acid fast at ARUP, and those are not convenient stains to prep. They're time consuming, they're messy, and they are generally only ordered on physician directive. We don't put them into every ONP in general. Some hospitals may. And as a result, I think there's a lot of misdiagnosis simply because the button isn't pushed. The other thing with those stains is they're tricky. They're very difficult to read. You can get artifact organisms like yeast, which superficially can resemble Cyclospora if you're not careful on measurements and shape and color interpretation. And you can get ghost forms, and ghost forms are basically when the oocyst wall occludes the stain. And that's one of the reasons a standard ONP using a trichrome isn't employed for routine cyclospora diagnosis is because in trichrome it never picks up the stain. In acid fast, it picks it up, between 25 to 50% of the time. And in the modified safranin, it's a little bit better. But, we've got a combination of a test that's not ordered, a test that's not offered, And a test that when it is offered isn't great, right? It's not the easiest to interpret, and it's insensitive in general. Then the other side of that, the next step is molecular, like I alluded to, but a lot of NAT tests don't have this target. So, you're blind to it if it's not on the panel.
So multiple factors.
It sounds like there's definitely room to improve. Angela, with all those challenges that Mark mentioned and the caveats about the quality or the sensitivity, rather, of the testing, you and your co-authors evaluated an alternative approach. Tell us about that. Tell us how it works and tell us what the advantages are.
Yeah, so we focused this manuscript on looking at the autofluorescent properties and using UV fluorescence microscopy as a means to detect cyclospora. And it's nothing really new, actually. It's been well recognized and, it's in textbooks and things like that for decades. But, it's kind of not really been routinely implemented in some labs, perhaps. And it's a great method to be utilizing. The parasites have amino acids or derivatives within its cell wall that naturally form these cross linkages that autofluoresce at wavelengths anywhere between, 300, 330, 365 nanometers, and also at, within the 450 to 455 nanometer range. And if a laboratory does do mycology and, calcofluor white methods and things like that, and they have a fluorescence microscope within their lab, simple wet mount preparations of concentrated stool specimens can be examined using the same equipment. You don't have additional instrumentation or costs with that, and you're just really looking to see autofluorescence as long as you have the equipment and the appropriate filters there.
So, Angela, are there any reagents that can interfere with observing that autofluorescence? Are there any pathogens that could be misidentified using this approach as cyclospora, but it's not cyclospora?
So what we do know is that iodine that's commonly used for looking at wet mounts for stool specimens on light microscopy, that does interfere with it when you're using UV. So don't add iodine to that. And then next that you wouldn't really be adding much else to a wet mount there. It also does identify cystoisospora as well, the other coccidians, sarcocystis, and then also a variety of different helminth, especially nematode eggs as well. So that's almost a bonus if you're familiar and have the expertise to be recognizing those in your laboratory, as they all do autofluoresce. There's absolutely going to be other things that can be mistaken for cyclospora or any other kind of material that you're looking at with a fluorescence microscope. Like Mark mentioned, yeast is something that can glow with fluorescence microscopy, but it doesn't really have the distinctive size, shape, and consistency that laboratorians should be looking at when detecting cyclospora. Another thing is maybe just air bubbles, fat globules as well. And those kind of things can have the similar kind of shape, maybe not the same size, and it's not going to be consistent across the slide or in your sample as well. So it's really focusing on having all these things together with morphology, shape, and size together to be confident in making your calls.
Awesome. Thank you. So, Mark, can you take us through the methods that you used to look at performance of autofluorescence for coccidia? Kind of talk about the samples, any special stains done to look at autofluorescence, and also what was your comparator method?
Sure. So this is actually a study that when Blaine Matheson came from CDC to AREP and found out that I was doing UV already before he got here, he was really excited, and we were constantly seeing cyclospora positives, and I had said to him, I said, I'd love to do a study to look at, is this actually worth doing? Like, we have fun doing it, but is it worth it? Is it actually better, or is it adding anything? Because we have been doing it for a few years, and the lab's perspective was, it's, in many occasions, they'll detect stuff with the UV that they otherwise probably would have missed on the MAF. Sorry, the MAF is modified acid fast. Had they just had the modified acid fast to go by. But that was, again, it was anecdotal. It was kind of just, we inappropriately refer to as tribal knowledge, just passed down from person to person. Yeah, this is better, but is it? And so I was told plain, I'm like, I'd love to do a study. Let's start collecting specimens. It'll take probably 5 years. So I think we started collecting these a year before Angela started as a fellow. And it took a while to get enough.
I'm sure.
So, one of the things we said in our expectations is about sample size. I think the sample size is fantastic, but I know the field and I know how rare these are. But it took a lot of time. And so the method we used was, because this was already standard of care in our lab, everyone that came into our lab was trained on this from day one. So we basically say, okay, we want to collect all the positives, and the positives would have had to have been identified using our standard of care process, and that's going to be defined as the comparator. So in our laboratory, that includes a primary technologist who performs the UV wet mount and then reviews the acid-fast stain. If they suspect it's positive, they put it into a secondary review queue. A second technologist then reads it blindly, so they don't say suspect cyclo or suspect crypto or cysto. That just says review. Mm-hmm. Second technologist would then pull it, do a UV, review the acid fast, and then if they agree, that result would have been considered truth, and that was what went to the patient's chart, but it's also what went into our study set. Now, in the event that the two technologists disagreed, then myself or Blaine Matheson in the lab do a third review. That's how we do all of our results. And so that's how we basically enroll specimens into the study set. They had to have been through the standard laboratory process of establishing truth. Once truth was established through the standard process, that went to our positive specimen bin. Then the negative specimen bin was basically specimens that went through the primary technologist who read it as negative, and then those negatives do not get a secondary read. So those would have been a little bit less examined because we don't do double reads on negatives because we wouldn't have enough humans.
Yeah.
And so that's how we identified the positives and the negatives. Some of the positives were identified by different approaches as well, though I will admit some of the positives did not get an acid fast stain. If they came through as an O&P order and they were suspected for Cyclospora based on our AI model, which we trained on detecting ghosts, if it flagged it in the trichrome, we would then do an UV, confirm it, and have Blaine or I double confirm it. So, and actually it was a triple confirm after the standard two technologists. So everything got either two technologists and a specialty exam, or AI plus two technologists and potentially a specialty exam.
That's a lot.
That is a lot. That is a lot. Thank you, Mark. Angela, we've got the methods now. Take us through the results. How well did the UV autofluorescence stack up against modified acid fast stain?
Yeah, for sure. So overall, when we're kind of looking at how the two methods averaged out, the UV kind of edged out as superior just by a little bit over the modified acid fast that's performed at ARUP at 88.8 if we're really going to be talking about numbers versus 85.2%. In terms of false positives and false negatives, that's where we're seeing some of the differences, especially among the different readers or the technologists. The false positive rates for both methods were quite, very low. 3.2 for the UV versus 2% for the MAF. So you could say that the UV is a more, sensitive screening method, and the MAF is possibly more specific in that way. And then kind of we were seeing higher false negatives with the modified acid fast at almost, just a little bit over double that, with the UV fluorescence at 11.6 to 6.8%. But kind of how it broke down when we look at experience between the readers, as where some of the more interesting results were showing up. Maybe it answers itself when you have technologists that have, 5+ years of experience compared to a newly trained technologist that is competent, but, doesn't have as much real life bench experience, right? And that all comes in time, especially with something where you're rely so much on visual inspection, because we were seeing some higher calls with our false negatives, with our less experienced technologists than, our more experienced ones.
Mm-hmm. Yeah, I think that kind of goes to, I believe, Mark, you, Bobby, and Blaine, and a couple others wrote that really nice article in JCM was it years now back, arguing for really kind of the need of parasitologists able to identify things morphologically and how that takes so much time and expertise. And it seems like that really came out in this paper as well. So that was interesting. So Angela, you mentioned in your paper that a key strength of this particular study is the fact that it's the first kind of detailed comparison of UV autofluorescence compared to permanent stains. What would you say were some of the limitations?
Yeah, so I think Mark kind of touched on sample size already.
And can you share with us, I don't think we talked about how many positives you guys actually looked at.
Yeah, so we had 35 positive cyclosporas, 5 positive cystoisosporas, really as like the bonus to this study. And then we had the remaining 10 negatives. And like Mark mentioned, it's very good for what like a parasitology-based study on something that isn't, of high incidence in North America. So of course, more is always better, but it was really good for what it is. Some other limitations, and Mark kind of really went over in detail the standard process that the parasitology lab does. We did, in efforts to blind for the study, there was no like consultation between the readers. There was none of that second read verification of positives. So perhaps, that could have impacted, the decisions for the less experienced readers, perhaps, and what they called what ultimately were false negatives or false positives. There's also the potential for sampling variation. There was one set of modified acid fast stain slides that were made, and every reader read those independently. For the wet mounts, every technologist was making their own wet mount every time. So could there have been some sampling variation there? Possibly. We didn't have digital imaging or snapping of pictures of a camera to see what was being looked at by the readers at the time. So that led to some challenges with kind of going back to confirm, what was the false positive that was being called, even though Blaine Masson, being our expert that went back to back read all of these discordant results, was able to confirm, most of them.
Thank you. All right, so Mark, down to brass tacks. How did these results influence workflow or test utilization in your previous laboratory?
I'm just going to apologize. Are you guys hearing background noise?
Mm-mm.
Okay,
is it
perfect.
family?
I'm not. It's a washing machine that's unbalanced. The struggle is real, guys. The struggle is real.
All right. It's real life.
So like I said in the introduction, or one of the earlier parts of the conversation, we've been doing this method in our lab for quite a long time. I think, in fact, the results of the study didn't change anything. In fact, it reiterated what we've been doing, and that we don't want to change anything. I think had we done the study, and our assumption going in was that UV allows us to detect more positives than MAF alone. I think if we hadn't seen that, we might have reassessed whether it's worth doing the UV going forward. But, we saw enough of a diagnostic gap for a disease that's so low incidence in this country that even that small percentage, if you extrapolate that, that's a lot of cases that otherwise would have been missed. So we are definitely UV proponents in the laboratory that I recently directed, and it still is ongoing. In my place, Blaine Matheson has been kind of promoted to take over some of my duties when I left, and Blaine is a staunch UV activist, and he will be definitely fighting for the perpetuation of UV. It's also been something, a lot of colleagues have known that we've been doing it for years. And so we've helped other labs get it up and trained by providing them with materials and good specimens to use as training sets.
That's awesome. So Mark, your lab was one of the first, I think, to implement AI for ONP. And given that all of this interpretation was done manually by eye, would you foresee autofluorescence being something that can be done using AI in the future?
And before we answer that, one of the first or the first? Because I think it's the first.
Is it the first?
The first, yeah.
Awesome.
Yeah, so
now back to my question.
So it's a simple question, but it's actually kind of a loaded answer. So there are fluorescent scopes that can do AI, or the whole slide scanning and then digital imaging. And there are AI models already commercially available for other applications to interpret fluorescence output scans. So if they're being developed for immunology applications for stuff like ANA and IFAs like that, there's applications for AFB fluorescent stains. I think as awesome and sexy as it would be, we don't need it. And I'll say that only because the trichrome model is so amazingly good at catching Cyclospora. And we also have an acid-fast model that's taught. So all of these specimens that come through our ARUP, that go through ARUP's lab, now get AI on the front end by one model or another. Doesn't mean you cannot train a UV model to be looking for, 8 to 10 micron spheres and 25 to 35 micron football-shaped Cyclospora. I don't know that the effort is needed, though, with how good it is on the permanent stains. That being said, not every lab can use AI for parasitology. I'll be the first to say it's not cost-effective for most labs. And so because of that, why not use a tool that already exists on the scope that you use for your calcifluor whites? I mean, if you already have a calcifluor white screen, you've got your UV wet mount sitting right there ready to go.
Yeah, makes sense. Well, that's all we had. I thought it was a really interesting, simple to read for the non-parasitologist among us manuscript. And I'm really glad both of you could join us and take us through your study. So thank you, Angela, and thanks, Mark, for joining from your family home.
Thank you for bringing us in before your miraculous vacation.
I know. Probably shouldn't have put that in the podcast. We'll see if we can take it out.
My friend's living in his parents' basement. I'm going to go to Mexico.
We just need your parent to call from the background, ask if you're hungry, and get that into the podcast too.
I know. I'm just waiting for my dad to be like, "You want a beer?" No, Dad. It's 3:00.
Oh my gosh, Alex.
Yep.
We had some good laughs. It's good to see you.
Yeah, it was a good one. Have a great have a great vacation. Enjoy your time away.
Thank you. And thanks to all of our listeners. Please remember to subscribe and tune in for the next Editors in Conversation podcast in May.